As we learned in Exhibit C, Phil Plait does not dispute the fact that the ability to detect solar storms before they occur is fantasy.
A good-sized flare could indeed kill an astronaut very nastily and gruesomely. In a sense, the astronauts were indeed risking their lives to go to the moon, because solar flares are not predictable. Had there been a good flare, they might have died farther from home than anyone else in history. Luckily, the sun's activity was low during the missions, and the astronauts were safe.
Let's hear it one more time.
Luckily, the sun's activity was low during the missions, and the astronauts were safe.
That's weird, because that's not what NASA told us in the months that followed Apollo 16. In addition to publications by Dr. James Van Allen and John Malden, Ralph Renee also picked up on a NASA document entitled On the Moon with Apollo 17, a guidebook to Taurus Lithro. It can be downloaded from the Apollo Lunar Surface Journal on NASA's website, and was written by Gene Simmons, a chief NASA scientist. On page 51 of this document, regarding the Cosmic Ray Detector experiment, we are told, the CDR experiment was flown on Apollo 16, but a solar flare occurred on April 17 and produced many particles. The tracks caused by the solar flare particles are both larger and more numerous than tracks produced by the normal solar wind particles and cosmic rays, making the readings of the normal record very uncertain. We know that the energy level of normal cosmic rays, which strike the Earth from all sides, have an energy level as high as 10 billion electron volts. Therefore, this April 17 flare would have to have had an intensity greater than 10 GeV. The deadliest flares fall into the category of X-class, and NOAA 720 earned its X-class certificate with an energy level as low as 100 million electron volts, the same energy level as the Van Allen belts.
Solar flare. Very hazardous and intermittent, but they persist for 1 to 2 days. High energy protons travel at the speed of light, so there is no time to get under cover. Protected dose, 10 to 100 rem per hour. Unprotected dose, fatal.
We already know that solar flares can deliver 100 rem per hour. Further readings into the April 17 flare reveals that it lasted until April 19, for a grand total of 3 days. This gives us a maximum dosage of 7,200 rem. It's important to note that this flare occurred during Apollo 16. And yet, Phil Plait makes no mention of it in any form of media.
Honestly, it was just luck that there was not a massive solar flare during the Apollo missions. There was one in between two of them that was huge, and if they had been out in space, actually outside of the Van Allen belts protect the Earth from this stuff. They catch it like a net, and they feed it down into our atmosphere where it becomes harmless. Out in space, you get hit by a solar flare like this, you're dead. And these guys could have been on the surface of the moon during a flare like that, and they would have died 250,000 miles away from home of radiation sickness, which is a horrifying way to go. So these guys are true heroes in every sense of the word. They knew what they were getting into.
So
and
it was basically a solar game of Russian roulette.
That's right. It was just probability. I guess luck is probability taken personally. I believe the large man on my right said that initially. But it was just probability that they didn't that didn't happen.
But I thought that there were some big solar flares that supposedly occurred during the Apollo missions.
The words solar flare are simply non-existent in his review of the Fox special, even though the April 17 flare was briefly mentioned in that very television show.
A magnetic storm will come along, and that can increase the intensity of the radiation belts by maybe 1,000 times above what it was before.
According to Renee, The Apollo 16 mission coincided with one of the sun's most intense storms ever recorded.
Around the rotating sun came this immense flare, the biggest one of the 20th century. It went on for 3 or 4 days, all the while it's slowly rotating around.
The flare's existence and intensity was also confirmed by the Zigzag Productions documentary. And interestingly, we were told that NASA waited until July 1972 to tell the world about it.
Just 3 months after the Apollo 16 mission, NASA admitted that a violent solar flare hit the moon's surface, an eruption so powerful it could have killed the astronauts had they been there.
Even though he was the star of the show, Jay Windley would go on to deny what we were told.
We have records of solar weather from several observatories worldwide dating back to 1870. Everybody watches the sun. The notion that NASA could hide or misstate any significant solar activity is like saying the French government could plausibly conceal the fact that the sun came up this morning. It's simply too ludicrous for words.
And yet, as early as 1967, US Air Force satellites detected bursts of gamma rays with energy levels as low as 1 MeV, a discovery that was never revealed to the public until 1973. There is another problem in Windley's backpedal. If there never was such a deadly solar flare in the first place, why did the astronauts bother to shield themselves from it by putting the spacecraft's bulk between them and the incoming radiation?
Just 3 months after the Apollo 16 mission, NASA admitted that a violent solar flare hit the moon's surface, an eruption so powerful it could have killed the astronauts had they been there.
Solar flares are one of those things that you have to take a calculated risk on because they will zap you with radiation once they get to you, but you've got a long time, hours if not a day or more, to either come back to Earth, find a shielded place, or prepare yourself.
Astronauts could only rely on their spaceship to survive a solar flare.
And they had plans for this. The plan was to turn the bulky end of the ship toward the incoming front of radiation. That bulk of the ship and all the fuel in it would provide plenty of protection for that burst of radiation.
As previously stated, Olberg's explanation is ridiculous. Windley can deny it all he wants, but the protons from a solar storm travel to near light speed. There are many sources that state this, such as Dr. Tony Phillips, editor for Science at NASA.
Solar protons accelerated to nearly light speed by the explosion reached the Earth-Moon system minutes after the flare, the beginning of a days-long proton storm.
Ken Jenks, of the Space Biomedical Research Institute.
High-energy protons travel at a speed of light, so there is no time to get under cover.
And Gene Parker, the astrophysicist famous for correctly theorizing the solar wind. In the March 2006 issue of Scientific American, Parker writes, "The Sun, too, can unleash tremendous bursts of protons and heavier nuclei travelling at nearly the speed of light. Such bursts occasionally deliver in excess a couple of 100 rem over an hour or so, a lethal dose to an unshielded astronaut. Like, say, an Apollo astronaut. And yet, Windley would have us believe
these particles do not travel at the speed of light, or even at an appreciable fraction of it. They take many hours, and sometimes even days, to reach Earth from the Sun." The energetic particles are the part of the solar flare that does the damage. Those are the components that travel much slower than light and are to be shielded against by placing the bulk of the spacecraft between the particle front and the astronauts.
there is no question that these particles do indeed travel at an appreciable fraction of light speed. So just how long does it take for light to reach us from the Sun? Let's ask Josh Hawthorne of the Anglo-Australian Observatory